Today we're going to learn the method of substitution for solving a system of equations. So you can see that these two equations look different at the moment, and substitution lends itself to when one of your equations has one of your variables isolated, meaning it's all by itself. The reason we like that is because now it's an easy substitution. So we know that y equals 6x minus 11. So we're going to take that, and every time we see y in the second equation, we can substitute in 6x minus 11. The reason we want to do that is that it eliminates one of our variables, and then we can solve for, in this case, x. So I would rewrite the equation as negative 2x minus 3. I'm not going to write y, I'm going to write what y equals. Parentheses 6x minus 11 equals negative 7. As you can see now, we only have one variable, and we are going to go solve for it because now we want the x of the point of intersection. So I'm going to distribute this negative 3 to everything in the parentheses. So I get negative 2x minus 18x minus, or plus 33 equals negative 7. Negative 2x minus 18x is negative 20x plus 33 equals negative 7 minus 33. Negative 20x equals negative 40. Divide each side by negative 20. And you get x equals positive 2. So that is going to be our x-coordinate, positive 2. And we're going to take 2 and plug it back into one of the equations to solve for y. Personally, this is the better one. Okay, we don't have to do a bunch of monkey business to find y. Here, it'll automatically equal it. So instead of x, we're going to write 2. Y equals 6 times 2 minus 11, which gives us 12 minus 11, so y equals 1. Of course, we're not done. We need to check our solution, so we're going to take this coordinate 2, 1, plug it into that, and make sure that it works. And by that, I mean the second equation. Negative 2 times positive 2 minus 3 times positive 1 equals negative 7. Negative 2 times 2 is negative 4. Negative 3 times 1 is still negative 3. Negative 4 minus 3 is negative 7, and negative 7 equals negative 7. So we are right. The coordinate for where these two lines would intersect would be 2, 1. All right, what you guys are going to try next, you're going to pause the video, and you're going to solve this system of equations. 2x minus 3y equals negative 1, and y equals x minus 1. Let's solve it. So I know that y equals x minus 1, so x minus 1 can be substituted in for that y. So now my new equation is 2x minus 3, and whatever y is, parentheses x minus 1, equals negative 1. 2x, I need to distribute, negative 3x, positive 3, equals negative 1. So we have negative x plus 3 equals negative 1, minus 3 from each side. Negative x equals negative 4, so then x equals 4. Now let's plug x equals 4 into the bottom equation and solve for y. All right, y equals 3. Now let's check that coordinate in the top equation, make sure it works. And if it does, then we are right. So 2 times 4 minus 3 times 3 equals negative 1. So 8 minus 9 equals -1, and -1 equals -1. And that's how you use substitution. Again, it lends itself well to when you find a system where one of the variables is isolated, so then you can easily substitute it in to the other equation.